Good day everyone, my name is Daniel Chaparro and I will be presenting Quantifying Mouse Aortic Valve Leaflet Mechanical Properties. Understanding aortic valve tissue properties is important in determining the biological factors that lead to aortic valve disease, which is characterized as pathological remodeling of the tissue, leading to stenosis and/or regurgitation. Although mice are commonly used animal models for aortic valve disease, little is known about the tissue's mechanical properties. This is in part because traditional mechanical testers are not suitable for the tissue's microscopic size. Although there are current methods to assess mechanical properties of microscopic tissues, current methods that determine these tissue mechanics displays the tissue orthogonally to the primary axes of fiber alignment and can't comment on the anisotropic properties of the tissue. To combat these current limitations, we have developed a method by which the tensile mechanical properties of mouse aortic valve leaflet tissues can be determined. We resect the microscopic leaflets and carefully adhere them to a dopamine-coated silicone rubber membrane. The membranes are then equiaxially strained by pulling a vacuum over a sensor post. Simultaneous microscopic images at different loading configurations allow us to track displacement on the tissue surface. The calculated strain on the tissue surface recapitulated the classic orthotropic response seen in larger mammalian samples, in which the circumferential direction displaces less than the radial direction for any given load configuration. In the figure on the right, you can see the strain value for different directions on the valve. The vertical direction corresponds to the radial direction, and the horizontal direction corresponds to the circumferential anatomical direction. And you can see that there is a larger strain value in the radial direction than the circumferential direction. To better quantify this observation, we tested 6 mouse aortic valve leaflets and noted that the circumferential direction is about 155 kilopascals stiffer than the radial direction. As you can see, using this method, relative mouse aortic valve leaflet mechanical properties can be assessed using this method, where the orthotropic characteristics of the tissue can be assessed. However, the absolute values of the mouse aortic valve leaflet mechanical properties would necessitate decoupling the membrane and the tissue through numerical analysis. In the future, we plan to use this method to assess the contribution of active cellular contractions on mouse aortic valve leaflet mechanics to determine the role of neuromodulation of leaflet rigidity in aortic valve disease. This concludes my presentation. Thank you all for your attention, and a special thanks to Dr. Joshua Hutchison, the members of the Cardiovascular Matrix Remodeling Lab, and the Florida Heart Research Foundation.